Hi folks, I'm just recording this quick video showing you how to make a graph for your lab 2 density. So I've already gone through and I've done the density lab here. So one thing I found useful when I'm reading the volume, if I double click here and on my Mac I can push Command plus and see that really zooms me in and I can read that meniscus now like really well, okay? And I can hit Command minus, certainly for you PC users, right? You can say view and just zoom in. So I found that to be really useful for measuring the volumes. Okay, so I've gone through and I've done all of these experiment 3 procedures. Excuse me. And so I've got my data here in the essay. Um, so now to do the graph, you notice down below here, it wants you to create and save a graph of mass on the y-axis and volume on the x-axis. And display the trend line and determine the slope and intercept. The density equals the slope. So let's do that. So what I have here is Google Sheets, and you should all have access to Google Sheets because you have a Gmail account through HSU. So on your Gmail window, just say, new Google Sheets, okay? And so here I've copied my data, right? I just made a new chart. Let me see here. Right, so here's my, oh, excuse me, this is the one I want, right? The volume of water that I added each time, and the total mass. No, I lost what I was doing here. This one, okay. This is the aluminum, right? But what you're looking at, what you're looking for is not this density, but you want to note the net volume and the mass you added. So right, the mass went up by 15 grams each time, okay? So then I got the net volumes. And so if you do it volume first and mass second, it will give it to you as X and Y, just like it asks you. So now I'm going to select all of my data here like this, okay? And by the way, notice how I make these headers so I know exactly what units I'm dealing with and what my data is, right? A nice organized spreadsheet is a good thing. So I'm just going to select this data set, both columns. I'm going to say insert chart, okay? And look at this. This is cool. It kind of does almost everything for me. I'm going to make this a little smaller so I can see it all in one view here. So let's, yeah, there we go. So now I can see this a little bit better. Okay, so the first thing that I want you to do is take note that it's putting the data as a line, and we're going to put a best fit line here. When you have data, you should really use data points and not a smooth line. So the way we can do that, so I double clicked on this line here, okay, and right here on the point size, I'm going to say like, I don't know, 7 or something, sure. And then on the line thickness, I'm going to say 0. And that gives me only data points. I also want to change the scale of this graph because you notice my 60 data point is kind of offset way up there. And I don't really have any data below 15 grams. So I don't really need that data to be displayed. Okay, so what I'm going to do is double click on the axis. And then I can say, oh, here we go. Minimum value, I'm going to say 10. Maximum value, 70. Excuse me, I've been talking too much. Okay, so now I can see that I've got my axis nice. It's all centered with my data. And I can right click on one of those data points. And oops, that's how you do it in regular Excel. So let me double click back on the data points. So I double clicked to get this menu. And now I'm going to say trend line. There's my best fit line. And my label, I'm going to say use equation. And here's my equation. Pretty sweet. And so now what I can do finally with this, so you can see this has got a nice title. My y-axis is labeled. My x-axis is labeled. This is a good looking graph. Okay, so now I'm going to push these 3 buttons, and I'm going to say download. And you can do it as a PDF or an image file. Let's go ahead and say image file, PNG. And so I'm a good student because I have all of my classes organized by file and year and so on. So Chem 109, lab 2 density. So you can see I already saved this thing. So it's just going to say, yeah, I'm going to say replace it. And then now, so I can open up that graph. And look at this. What a good looking graph this is. Sweet. Okay, and now what I can do over here where it wants me to upload this graph. So make sure you're doing this for iron, right? You're going to do this for iron and aluminum, okay? So over here on my Mac, I can just grab this and drag and drop. For PC users, you should be able to click in there and upload it. And now I've got a nice digital graph uploaded. And then it also wants me to say, determine the slope and intercept. Well, here it is, right? My best fit line, let me move this over here, right? It's y equals 8.21x minus 2.11. Okay, so my slope of this is equal to 8.21, and my intercept is equal to negative 2.11. So my data is kind of crappy. I went through and did this kind of fast. So don't do it fast. I want you to try to get nice data. And so you can tell my data is kind of crappy because the data points aren't right exactly on the line. You know, a really nice, precise, and accurate data set will have all the data points along this line. But that's okay. I'm just doing this really quick to show you how to do it, okay? And so now the density equals the slope of the graph. And remember, slope is rise over run. And so the units of my rise are grams, and the units of my run are milliliters. So rise over run gives me grams over milliliters. So now from this, I can say that my density equals 8.21 grams per milliliter. And I can look up to see how well I did. Let's just ask the Google gods. Density of iron. Oh my God, it's 7.8 grams per milliliter. So I told you I did a crappy job. But this also, you know, you can use the internet to find data, right, to see how well you did, okay? And so you'll repeat the same thing using aluminum. So you can see I've already got the aluminum data. So hopefully this video, you'll be able to make yourself nice, sweet looking graphs and get the trend lines. All right, folks, hasta mañana.